also to kind of broaden my scope, because I'm not opposed to software development, but
yeah,
web development's more.
You may want to take web design.
More of my own. Yeah.
my turn, guys. Sorry, I'm late, but now I'm going to interrupt. Alrighty, so what is an algorithm? It's just a series of steps. Just like baking a cake has an algorithm. Add this much flour, add this many eggs, throw in the oven for this long. So here's an example algorithm for calculating gross pay. Ew, gross. Alrighty, so how many hours did you work? They type it in. How much do you get paid per hour? They type it in. Multiply those two things and then print it. Now this is pretty boring because it doesn't also include calculating overtime, if you're lucky enough to get overtime for an amount over 40. So maybe we'll turn this algorithm into C++ code, but then maybe we'll add the overtime calculator because we're awesome. So I'm going to go ahead and create a Lecture C and paste in my boilerplate. New project. C++, empty project. If you choose console application, which is a natural thing to want to choose, then Microsoft adds some Microsoft specific stuff to it. We don't want to learn Microsoft specific. We want to be able to write code, you know, for any platform. So that's why we go ahead and do empty project. Takes a couple extra steps, but that's okay. Lecture C.
Mr. Thompson,
Mm-hmm.
one thing I'm going to ask, how do you code two programs into one project? Because I had problems with it. It said .exe file is missing or whatever.
I just put them one after the other inside main. If you want two programs inside one project, until we learn about writing your own functions, I would just put one after the other inside a main. Just like when we're going in class, right? We just keep going and going and going. You can do that. You can put the first problem and then the second problem all right in main. Good question.
It'll just be two outputs. You give you the output for the first answer and then the
Exactly, exactly.
The next question.
Right, right. All right, I loaded it up. My Solution Explorer is kind of hidden off the side. If I couldn't find it, I would do View, Solution Explorer. I know I need my boilerplate. I hope you've saved it. So I'm going to go out to my desktop and or wherever I save my boilerplate and find it. Maybe I put it in 1173. All righty, good old boilerplate. Why don't I save this as a text file and upload it to Canvas? That might make us happy. All right, I'll do that.
I need to put this in my Google Drive. Paste.
All right, save yourself some time. If you don't have the boilerplate, you can just go to Modules, Class Information, and then there's the boilerplate. So I'm going to copy that stuff, paste it into a new file. So I'm going to go to Source Files, right-click, Add, and of course it's completely different for your Mac users, but that's okay. New item, Lecture C.cpp, although I don't care if you call it source. It's better to have the actual lecture name or homework name. Lecture C. Paste. Whoa, that looks lousy. All right, guess what though? This would almost work. It won't work, but if I had these two lines on their own lines and then ran the rest of it, it would still work, even though it's all squished on the one line. Now, I did not want my boilerplate to look like that. I'm kind of disappointed it did.
It actually did do that to me.
Oh, awesome. Even better. All right. So anyways, I'm going to fix this the way it's supposed to look, and if it's giving you grief, just, you know, make your own boilerplate file, save it to the desktop. Okay, so what does our algorithm say? Our algorithm says that we need to display a message, wait for the user to enter the number of hours, display another message, wait for the user to enter an hourly pay rate, multiply those two things together, and then display a message that tells the amount of money earned. We can do that. If you ever get stuck on a programming problem and you need me to provide the algorithm, ask and I'm liable to do it. So, ask the user for a number of hours. Well, firstly, why don't we tell them what we're doing? Let's tell them that this is a pay calculator. So even before we ask the user for the number of hours, let's just display a message saying that this is a pay calculator. So cout less than, quote, pay calculator. Now I could do the ENDL business. I can also do \n. You'll see me swap between those two just to get you used to the idea of \n, because you use \n in Python and Java and stuff like that, and you do not use ENDL. So \n, the backslash is the one above the enter key, not under the question mark. Semicolon. So we're going to ask the user for the number of hours. It's another cout message, right? Got to tell them. Cout less than, how many hours did you work this week? Question mark. Space. Semicolon. Now I could put an ENDL or a /n, but then it would go to the next line for the input, and it's kind of nice to let them type it in right then and there. And sometimes I even like to give them an angle to indicate where to type. So I'm going to put a quote there. I mean a greater than right before the double quote, semicolon. Now we need some variables. I could have created the variables up at the top, or I could create them on the fly. It's prettier, it's more structured if I create my variables up at the top. What do I mean by that? As the first part of main, why don't I go ahead and declare the variables? I need an hours variable, a rate variable, a total, and then maybe we're going to calculate an overtime bonus. That's like 4 variables. So double space hours, comma, rate, comma, pay, comma, bonus, semicolon. And if I have to add more variables, I'll come back up and edit them. Now that I have those variables, I can ask for that input. I mean, I have asked for it, but now I let them need to type it in. So CIN greater than hours, semicolon. Now we're going to do the same business, except let them type in the pay rate. I'm fond of doing copy and paste, but I'm going to rough it and do cout less than, quote, what is your hourly pay rate? Question mark, space, greater than, end quote, semicolon. And to let them type it in, what are we going to do? CIN greater than rate. Now I don't know if I made this point strongly enough last Thursday, but variable names only matter to humans, right? Variable names do not matter to the computer. We could call them anything. Like, for example, what is the Korean term for hours, right? All right, let's do Google Translate. Let's go, hours is English. I wonder what it is in, Korean. Ooh, that's not going to work. Okay, Sigan. Alrighty. Okay, SIGAN. Okay, so, I could have that, Sigan there, and as long as I use that everywhere, great, it'll keep working. Or, Tony Stark, right? I could have made my variable that. Or I could have made it like that, right? As long as I, as long as I use it, right? Don't type that, right? But anyways, as long as I use it consistently, it works. But that's stupid. So I'm going to go ahead and change it back to hours. Single letter variable names you can use for counters. I could have just called that H and R and P and B, but it's better to give a whole word so that somebody looking at your code, or you yourself a year later, actually can read it more easily. That's why I didn't just use H, R, P, and B. On the other hand, when I'm typing in sample code, like I just want to show what it looks like if you raise one number to the power of another, I'll probably just use single letter variable names because they're easy to type.
If you have more than one word, do you have to use camel case or?
You don't have to. Good question. If you have more than one word, like what if we actually wanted to use the word pay rate? There's a couple ways you could do it. Pay rate with a capital R in the, that's called camel case because it's got a hump in the middle like a camel.
That's what we use in Java.
Yeah, that's what you use in Java.
We use that in programming logic.
Yeah. Old school users from the coders from the 70s would probably use underscores. You'll see me accidentally use those when that is more common.
Well, either or work.
Either one works as long as you use it consistently. Yeah, underscores work just great. Camel case works just right. There we go. I undid that change. I hope you did not follow. It still says hours, rate, pay, and bonus. All right, let's calculate their pay, which is just the hours times the rate. Pay equals hours times rate. And now let's display that. Cout, less than, quote, total pay, or let's just say pay, because if we add the bonus to it, then we may want to call that the total pay, right? Pay equals space, end quote. Let's put a $sign in front of it. $, end quote, less than, pay, less than, ENDL. You'll notice a little bit inconsistency about how I do things. It's okay, but I do \n if I am inside a quote, but if I'm outside a quote, I just use ENDL. I could replace that with quote \n, end quote, right? That would work just as well, but when I do it, I usually do ENDL if I'm not inside a quote, and I usually use \n if I am. On the other hand, you can always just use ENDL everywhere. I could change this top line to do that. Now I'm going to undo that. You don't need to do that, but okay, there we go.
I have a question.
Yes, sir.
So, I mean, for the cout lines where it has what is your hourly pay rate, and how many hours did you work this week? Could you use ENDL instead of the greater than signs if you needed?
Yeah, you could. Like, okay. What if we did? What if we took that out and did ENDL? Well, let's run it both ways. Firstly, I'm going to run it with the greater than signs. You just develop your own programming style. That happens to be mine. I like seeing the greater than sign to let me know where to type. But, right, you could put ENDL there, and then when they run it, they're going to type in underneath it. Totally cool either way. Does that make sense?
So \n, ENDL, and the greater than signs are 3 different ways to end a command line, right?
Sure, except ENDL and \n are exactly the same. They don't show up on the screen, but they go to the next line. And the greater than sign certainly does show up on the screen. All right, let's see if it worked.
I'm just going to put $25 an hour.
Yeah, I worked 40 hours this week. I earned $25 an hour. Must be nice. Okay, I earned $1,000 that week. So let me wander around, make sure that everybody's up at the same point, and then maybe we'll add the overtime calc. Alrighty, gang. I have no idea how long the recording has been paused. So I'm just going to scroll up and down, and if you're watching the video, you can finish typing in your code. I'm sure that we got to about this if statement. So there's our if for calculating the bonus rate. There's our calculation for the new pay rate. and then we had a pair of cout statements to print our bonus and our total. And then we tacked on a little comment here about or and, just an answer to a question. You don't have to have that. And then lastly, a system, and then pause, and then a close brace. All right, that's where we are. We have successfully implemented the pay rate algorithm, and we even added something to it. Now, if you work in a company, what's probably going to happen is somebody's going to write specs, and then you're going to implement the program, and you're going to show it to them, and they're immediately going to find things that they wish you would change. Right? But I wanted to... Right. And so, yeah, but I wanted it to calculate bonus, but you didn't tell me to. And so then it's a big negotiation process. You know, they put in new requirements, and then you redesign your algorithm a little bit, and either then you go and code it or you hand it off. Sometimes you have different people dedicated to designing the algorithms and implementing the algorithms. And then sometimes you have different people responsible for correcting the bugs. Like if you enter 0 for the rate and it crashes, that would be a bug. And so a developer, a so-called maintenance developer, would get a bug report telling them to go fix that. So, you know, in a large company, it can be, you know, broken up into lots of little people, and not little people, lots of roles, you know, in the team. You will have a testing department trying to find ways of breaking your program, because what a programmer does is they write a program and they run it to see if it works. Right? I calculated the rate. I wanted to see if it worked. I saw my rate. It looked good. I thought my job was done. But then the testing department might notice that the program crashes if you typed in a rate of 0. I didn't think to try that. And so then the testing department tells you to fix your code.
Bad data.
All right. So, machine language. I did get up here and drew chip in a box, right? I did that lecture. Well, machine language is just what feeds the chip and makes it run. It's the series of opcodes expressed in numeric form, you know, the numbers, the binary numbers. So a computer only executes machine language. In this language, it gets compiled into an executable file. Java and Python get compiled into an intermediate form called bytecode, and then an interpreter turns that into machine language. The advantage of that is that that interpreter can be written for multiple platforms, Windows, Mac, Linux, Raspberry Pi, you know, your microwave oven, your phone, or whatever. And then the same code will run on many different devices. The advantage of making an executable, a .exe, like we do, is that it's fast. That's why video games are written in C++ and not written in Java. And yeah, you can get a game library and write a primitive game in Java or something, but it's not going to be something that you would, you know, that you would sell and you know, people run on their PlayStation, you know, or download and run on Windows. Pardon me?
We made a lot of money with Snake.
Yeah. So programs and programming languages. A low-level language used for communication with the computer hardware directly. Often written in binary machine code or something that gets turned into machine code very easily. Like, I think I already showed this, but the hello world in assembly. There's a program called a compiler that takes this code, and each one of these is an opcode that tells the chip to do something. This is just to print out the message hello world, which we could do with one line of code. Cout less than hello world. That's because C++ is a high-level language, meaning that we can ignore all the little itty-bitty details like this. Not very many people write in assembly programming anymore. But, you know, the software that ran the moon missions in the 60s and 70s was written in assembler. You know, Nintendo games for your 8-bit Nintendo and for your 16-bit Genesis may have been written in assembler. But nowadays, games are so large and complex that they're written in higher level languages like C++. Most software is written in a higher level language.
That would have taken a long time.
Yep. It would take a very long time to write this kind of stuff. You have to be extraordinarily careful not to make any mistakes. It's not easy to write this kind of code. It's not impossible, but it's not easy. And if there had been a mistake in the, in the Apollo software and then the moon lander had crashed, and some programmer would have felt very guilty. Thankfully, that didn't happen. Lots of high-level languages. Go ahead. So, I did this lecture already. We create a file using a text editor, and then a preprocessor runs. And what does a preprocessor do? It takes these #includes and brings the file in. It's also called a macro language, and I'll show you what I mean by that. We could modify our programming language like this. And you're not going to normally do this, but define the word print as cout. Then if I wanted to, I could do print >n quote hello \n end quote semicolon. And what does a preprocessor do? Every preprocessor command is prefixed by the #. And so when the preprocessor ran, it would take that word print and replace it with the word cout, so it would still work. And you could kind of almost write your own language, right? You could, do another #define that meant double, and another #define that meant the arrows and stuff like that. Now, you don't want to do that. You don't want to make your code as difficult to read as possible, but you can. So these are preprocessor commands. Everything that begins with a hash is a preprocessor command, and the preprocessor takes your file and modifies it in memory following all these dictates, right? It includes these other files. It does kind of a search and replace and changes everything from that word to that word, and then it's ready for compiling. So the compiler runs and changes it into machine language, and it's saved in an OBJ file, an object file. And then a linker runs to hook up those OBJ files and turn them into an executable. Fortunately, we're using an integrated development environment, so all that happens just with 1 or 2 clicks. Yes, sir. Sorry.
So are newer languages just trying to get more user-friendly?
Yeah, languages get written and created to try to fix something that the programmer doesn't like about a prior language, or to run more efficiently, or to make it easier to program. Because you notice that C++ is a great language, but it descends from something written in the 70s called C, which descends from something written in the 60s called B, and then to print out hello took several lines of code, whereas in Python it just takes 1, right? And so some programs are written to be easier to write the code. Other languages are written to be powerful in other ways, like there's a language I believe called R for creating graphs and stuff like that. And so it's got a different syntax because it's specialized to do a different thing.
My stepdad used to use that one.
Yeah.
R?
Yeah. I don't know exactly what it's for, but we were living in Monterey, California.
Yeah.
He was doing like operational analysis.
Oh, cool. Yeah. So for numeric analysis and creating graphs and stuff like that, you might use a different programming language.
It looks like TextPad basically.
Yeah. So what is a program made of? Sugar and spice and everything? No, it's made out of keywords. We've seen lots of keywords already. Double and int and void and using and namespace. We're not if now. We're not allowed to use those words as our variable names, but fortunately we don't really want to create a variable called if or while or using anyways normally. There are the programmer-defined identifiers. So, you know what? I'm going to undo this change. I don't care about print. There we go. Right? That is an identifier. It's a variable name. I got to make it up, and just like I said, right, I could call it anything I wanted to. So identifiers are the things you get to pick. All the blue things that show up here, if you have the default color scheme set up, are the keywords. Operators are the symbols. Less than, plus sign, equals, ampersand, ampersand. All the things that are not words are operators. And then what's the punctuation? The punctuation are things like the, what else have we seen?
Curly braces. Like
And
in
semicolons.
HTML.
Exactly. Right. So those are our punctuation. What does this do? It groups together blocks of code. What does this do? It either groups together mathematical expressions or parameters in a function call. We haven't done a lot of function calls yet. Let's throw in a function call just for fun. Int z equals POW 3, 4 in parentheses semicolon. Now there's a high likelihood that our Mac users are going to get a syntax error when you do that because Microsoft is non-standard and brings the POW function in by default. The Mac users and the Linux users and people using GCC, a different compiler, have to add a different # include up at the top. I'd like to remember what that is. POW function C++ include. It's part of the CMath header file. I'm going to add that to my boilerplate so that it's always available to me because there are lots of math functions in it. So up at the top of my program, I'm going to do # include less than CMath greater than. And great, that means I have something new to upload, right? So I'm going to go to my boilerplate and I'm going to add that as well. # include less than CMath
Can you
greater than. Yes, sir.
Can you put the two forward slashes and then the # as like a, can you put that as a comment and then put format or whatever instead of,
Yep.
you see what I'm saying? I didn't
Yeah.
know if the # would like supersede the slashes.
Oh, good question. Am I allowed to put comments inside after preprocessor commands? I don't think so. Let's find out.
Let's find out.
See if that's a syntax error or not. It worked. If we had done that in that # define, I'm not so sure it would have worked. Well, we could find out. # define print cout. See if it works. Nope, now it's complaining. So, it's okay to add comments to some things, but not to # defines. Pretty much comments are safe everywhere else except for # defines and a couple other preprocessor comments. Good question. Yes, sir.
Oh, I'm just stretching.
Oh, okay. Good idea. I'll do it
It's
too.
like,
All right.
yeah, you're doing this to me. What?
And then there's the syntax. The syntax are the rules, the grammar of the language. Python has a syntax. This language has a syntax. Python syntax is that you have to have a colon there, and then everything has to be indented underneath the colons. In this language, you don't put colons, and indentation is just for your own fun, right? Doesn't have to be indented. Now, this is lousy, right? But it's valid code, and there's absolutely no way that that would work in Python. Python is very dependent upon the syntax, upon the indentions. And in this language, you instead use curly braces to denote blocks of code and semicolons to mark the end of a line. And so indentation is not important, but it's very helpful, so we go ahead and do it anyways. Another example of syntax. I can't do this. I already have a variable called z. I could assign 5 to it. Right? That's good syntax. 5 equals z. That's good algebra, but it's not good syntax. In just about every language I've ever seen, the variable has to go on the left-hand side, and the value or the expression has to go on the right-hand side. So, bad syntax. Bad. All right. So, other things of syntax. In Python, you can do this. If z equals 5, then do something. In this language, the ifs and the whiles have to have parentheses around them. So that's Python syntax, doesn't work. in C or Java. Instead, we would use if parentheses z equals 5 in parentheses. So the syntax are just the rules the language has to follow. And if you mess it up, the compiler lets you know about it. Right? If I leave out, a closing quote, yeah, it tells me about it right there. But even if it didn't, then when I ran it, there'd be an error list that I could check and find it. Now, sometimes one mistake will lead to a lot of errors, right? Oh my gosh, my program's totally messed up. I'm lousy. I have 5 errors. No, just fix one of them, and then often a whole bunch of the other ones go away. So, new line and constant. What does that mean? Well, that's kind of alienish. I don't remember putting a new line and a constant. Well, everything between the quotes is a constant string. And new line just means that we didn't close our quote. We never found the closing double quote. And so it hit the end of the sentence, of the line, of the command, without closing the double quote. And you get used to translating this, high-tech, very specific language into the English that you need in order to actually solve it. But you see what I mean about how it created 5 errors because of one syntax error? Now when I remake it, when I rebuild it, there, all the errors disappeared. So don't panic if your error list is 100 lines long. Just fix the first thing. Then it may be 50. Fix the second thing. It may be 10, right?
It may be.
So the keywords are also known as reserved words. C++ has a heck of a lot of them. Not sure why there's not a list of them. Operators are the symbols. One more thing that I'm going to make as a comment, and then I'm going to give the homework assignment. If you have a statement like this, z equals 1 times 2, the asterisk is the operator. And what do you call the 1 and the 2? Who remembers that from like fundamentals or Java? 1 and 2 are the operands. Operands are the pieces of data that the operators work on. Operands are the pieces of data that the operators work on. All right, homework. Anybody in here also in my Python class? I don't think that's true, but
I took your Python class.
But you took it, right? But this semester, no. All right. So this I'm asking because this is going to be the same homework assignment that I just gave my Python students. All right. So write a program that asks the user to input the height and width of a rectangle. And remember, you don't have to type all this because I upload the homework assignment. Have your program calculate the perimeter, the area, and the diagonal of the rectangle. Now, it's the diagonal that's a challenge. The reason why is this language doesn't support ampersand, ampersand to mean power of. You got to use the POW function. So let's give ourselves our formulas. I think I made my Java class look them up, and I think I'm going to give them to you. So the formulas is that area equals height times width. Perimeter equals 2 times height plus 2 times width. And diagonal is Pythagorean theorem, which is the POW. Oh, this is a long formula. This is a real drag. Of height times height plus width times width. You know what? If we include C math, we ought to get a square root function, which would be better than using POW. Let me make sure that that's actually the case. I'm going to go back to my code and find out like what the square root of 4 is, just to make sure it's 2.
Will it not let us do just like a squared plus b squared is c squared?
Well, and then you got to take the square root of it. But you don't have a ampersand ampersand operator to do the squaring. So you have to use POW if you're going to do it that way, or just height times height and width times width. So anyways, let's see if the square root function works. Z is equal to SQRT parentheses 4. Yeah, that's going to work. So that would be a better formula than what I was just about to give you. Okay, like that. Those are the three formulas you need to use. Then display the three values. Don't just print out 10 and 20 and 22.5 or whatever, right? In the format, you know, height or, you know, area equals 60 or 200, you know, and then perimeter equals 60, and then the diagonal equals 23.6, blah, blah, right, whatever. It's not going to be precise. Okay. Now, this is if you enter the numbers 10 and 20 as your height and width. And that's not a precise number. I just made that up. I know it's 23.6, but I don't know anything. I don't know the rest of it. All right. I don't know why I displayed that. These values would result if the user typed in 10 and 20 as the height and width, but that last value is certainly not correct. I just made it up. Okay, that makes sense, guys? You're going to ask for two values, you're going to do some calculations, and then you're going to display the results. Yes, sir?
On my program, the overtime, it doesn't get calculated at all. It's literally the same as the regular pay.
Oh, well then let's look at that. But firstly, I'm going to create the Dropbox, and so people who want to leave are going to be able to. So does the homework assignment make sense, gang? Yes, sir.
Could I get the sheet?
Yeah. Let me print it out for you because I know that we went on further. Anybody else need a printout from today?
Sure. That's what I was gonna ask.
2, how many? 3, 4, 5. All right, guys. No, I'm kidding. Don't raise two hands. I'm not going to give you 2 copies. I'm making a joke there. All right. How about 6 copies? Yes, sir.
Can you post it on campus?
Oh, I always post my notes on campus. Always. If you don't see the notes on campus, complain, but I usually remember to give them there. So if you raised your hand because you weren't sure the notes were going to be on campus, well, next time you know that there will be. I don't mind training.
Let's see.
All right.
Well, let me go ahead and do my program. I worked 100 hours this week. My hourly pay is $30 an hour.
Yeah.
That's prorated.
Yeah. Good one, dude.
I think I forgot to add a formula.
Here's page 2. Here's page 2. Yeah, you can look at the formula right there. Page 1 and page 2. Review page 1 and 2. Let me make the Dropbox so that you can upload before you leave. And even if you don't finish the code, it's okay just to upload it. Yeah. Anybody else? All right. I have copies to take home.
You ever use Office Lens?
Pardon me?
The app Office Lens?
No.
You can take a picture.
Oh, I
of
forget.
paper.
Oh, yeah?
You can take it sideways and they'll spread it out for you. I did
Cool.
last semester on some whiteboards. that had
Yeah.
a bunch of stuff.
Oh, that's cool.
I can stand at an angle, it'll flip it for you.
I made a typo. What the? It's not that.
Excuse me. Excuse me, Professor Everett.
Yes, sir.
Already out more copies, or because I raised my hand.
Oh, you did want a copy? Here you go.
Yeah.
Sorry.
Yeah.
I didn't think
You got a problem.
Thank you.
Certainly.
Why is the gross pay paid in Spanish?
Yeah. Okay. All right, there's a Lecture C. Click on assignments. You'll see it.
Screenshot.
You don't have to do screenshot on the lectures, just homework.
Oh, homework.
Yeah, just homework. I'll add that as a comment. Upload a screenshot and the source code. You don't need to do screenshots for lectures.
We don't have to do screenshots.
Not for lectures. I mean, you can, but kind of a waste of time, huh? I know you're here, so I know you did the work.
Hey, Professor, it won't let me submit to Lecture C.
Ooh, is there a problem with it? Let me look.
Here you go.